Hello and welcome to another video. In this video we're going to be working on maximum XOR for each query. And in this one you're given a sorted array of nums of n non-negative integers and an integer maximum bit. And you want to perform the following query n times. You take a number that is less than 2 to the maximum bit and you XOR every single number in nums with that number. And then you get rid of the last number in nums. And you want to return the best number you can pick here to XOR all these with. So in this first one, let's kind of actually go through this. So 0 is just 0, 1 is 1, 1 is 1, and this is this. So the XOR of this whole thing is this. And so you would want to, let's see, yeah. And then you'd want to maximize, and also the biggest number you can pick is 2 here squared minus 1, right? It has to be less than this. So the biggest number you can pick is 3. So you're basically saying, given this, what's the biggest number I can XOR this with up to 3 to get the best number ever? And so 3 is just this. So ideally, we want to basically change as many ones to zeros, or as many zeros to ones as we can. So XOR, if you're not familiar, this is 0, this is 1, and this is 0. So because these are already 1s, and my number that I can XOR with only has 2 bits, I just want to XOR with 0, because I just want to leave it the way it is. So once you do that, then you get rid of the last number here, and then we XOR the 1 and the 1, and so the 1 and the 1 gives you 0, and I can XOR it with something up to 3. So 0, I want to change every bit into a 1 that I can, so the best number to pick would be 3, because then when I XOR those, I get 3. So essentially, it's basically, you go through your number up to the number of bits that you can have. So let's say your number is like this, and you just say, like, for every 0, I want my number to have a 1. So like here, I'd want this number to have a 1. Here, I'd want this number to have a 1. If it was this, then I want my number to be this, and so on, right? Because then you basically want to get 3 at every single time. So here it would be 3. Then we get rid of this number. So now 1 by itself is just 1. And what do we want to XOR that with to get 3? We want to XOR it with this. So this is 2. And then the last one is just 0. So 0 is just 0. Once you get rid of this number. And you want to just XOR that with 3 again. And so let's go through example 2. Kind of the same thing. So the biggest number we can pick is 2 cubed, which is 8 minus 1, so 7, which is just this. So if we XOR all of these, so 2 is this, or 2 is this, 3 is this, 4, 7. So if we XOR all of these, we get our 0, 1, 0, and we want to get this. So what number do we pick? Let's actually move this down a bit. Yeah, so basically we would want to just pick the complement of this, so 1, 0, 1. 1, 0, 1 is 5. So we're going to get 5 here. Then we get rid of that number, which is getting rid of this number. So now our XOR is 1, 0, 1, and then we want to get this to make it a complement. So this is 2, and you'd get 2. Then we get rid of the last number again. And now our XOR is 0, 1. And so we want to get this. So we just go 1, 1, 0, which is 6. Yeah. Then we get rid of this. And then our number now is this. And so we want to go 1, 0, 1, which is 5. So that's basically how you do it. And this is going to be the exact same thing, same kind of thing. So let's just kind of write down our steps. And the main thing I forgot, so for constraints, it's 10 to the 5th, so you're looking for like linear or n log n, and this would be linear. So for our steps would be like XOR the entire array. And then to perform these queries, we basically figure out like what's the biggest number we can get. So calculate biggest number. And that number is just going to be 2 to the whatever k minus 1. Then, so there's an XOR pattern that you can learn, which is if you do A XOR B equals C, then you can shift these around. So you can do A XOR C equals B, and so on, right? A equals B equals, or A equals C equals B, and so on. So basically, we have A, which is like this array total. So we can call this like array total. XOR some number equals our best number we can get. And the best number we can get is this 2 to the k minus 1. And so X is just going to be the array total XORed with 2 to the k minus 1. So whenever we get these totals, we can just XOR it with this number we calculate. So in this case, it would be this whole thing together, XORed with 2 to the 2 minus 1. And then you get rid of this number, and you do that. And it's pretty easy to get rid of the last number in the XOR because there's another thing that's A XOR B. XOR B is just A. So to get rid of the last number, all we have to do is just XOR our like total with that number. So our original thing will be like XOR the whole array. And then if we want to get rid of a number, we just XOR that with that number. And then that gets rid of that number. Because if you XOR something with a number twice, it's basically, it cancels it out. So that's essentially our steps. So we calculate the biggest number, and then we do these queries. Queries of array total XOR, the biggest number. And then we get rid of last number by doing array total XOR that number. And we just keep going and we can fill this all out. So just some simple XOR properties, and honestly, I didn't know them. You can kind of just like try XORing, and like there's a bunch of stuff that you can figure out. So that's essentially what we're gonna do. So let's do that. Okay, so we're gonna get every single number, XOR them together. I don't think we can get an overflow. Yeah, because if it's like 10 to the 5th or something, like XOR doesn't like make numbers. It can only make it as big as the most significant bit. So I think it's fine. So we'll see what happens. So we'll just say like nums XOR with that. Now we can get our results. So our result is going to be the same length as nums, I guess. Yeah, so you can say like int array result equals, and this is going to be the same length as this. Yeah. Then we can say for int I equals 0. We can do it either way. I guess we'll do it this way. Yeah, sure. So we're gonna calculate this guy. So res I equals XOR with, oh, we need to calculate this like maximum bit. I'll just change this to K. So K equals, it's like, do this. So it's going to be 2 to the, or I guess this will be like the biggest num or something. This will be 2 to the K minus 1. And I need this to be an int. Okay. And then this will be XOR biggest num. And we need to get rid of that last thing. So this should be res I. And then we need to XOR with the last number in the array. So I think this is going to be something like XOR this. Nums length minus 1 minus I or something like that. See what happens. And then let's return the result. Alright. Okay, and there we go. So yeah, some just basic properties of XOR. To maximize numbers, you just XOR zeros, ones, zeros, and yeah. And then let's say our number is like this, by the way, I guess I didn't mention this, and the biggest number we can have is like this. Like anything to the left of the number doesn't really matter. Like all of these values don't really matter. All we need to know is these values, I guess. Yeah. And let's actually look at the constraints here. Get to the maximum bit, and then yeah, because basically, like, no matter what this is, this will never change. So the only part we care about is this part. So we can basically just say, like, let's just ignore this section. It doesn't really matter. We're only trying to maximize this side because the side to the left, no matter what I XOR with here, I can never change these digits. So this is basically just like irrelevant. Okay. And this is... So XORing two numbers is technically log of the number, but because 32-bit number, basically constant time, log 32. So we XOR every number in the array, which is log n, or n. And then do we store anything? So we store this XOR number. We store this biggest number, but that's nothing. So I think it's just this. Yeah. So just some simple bit manipulation, I guess. I guess this has a pretty high pass rate. So definitely a decent problem if you want to like get into bit manipulation, figure these things out. Yeah. So that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.